Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NTA exam, PhD exam, SET, Jest, TIFR, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 19th of the mathematical physics. Before starting the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so we are studying differential equation. This is the fourth part of the differential equation. Okay, so I'll start now, and so we are we are solving how to solve particular integration, right? So this is the case number third. Okay, first and second case was already discussed in my previous class. You can check it. The third case is if Rx is in the form of e to the power ax and phi x. Okay, phi x is a any function of x. Okay, so if this is in the form, then particular integration is going to be f d e to the power ax phi x, and then it is going to be e to the power ax into 1 upon f d plus a. Okay, instead of d we'll write d plus a and phi x, and then we'll solve it. Okay, so this is the particular integration. Okay, and if this is the type of, if Rx is in this type, then we find particular in this way, particular integration in this way. Okay, so I'll start. I hope guys I'm audible. Okay, so now I will solve questions, so then it will clear your doubt. Okay, so question number first. Question number first is d square minus 2d plus 1 into y equal to x square e to the power 3x. Okay, so this is in the form of this, right? So how to solve it? We'll find first auxiliary equation. Okay, so I would request you, please watch my previous classes of differential equation, then it will clear your all doubts. Okay, so auxiliary equation is going to be, I have explained each and everything in detail. So m square minus 2m plus 1 is going to be 0, and so m minus 1 whole square is going to be 0. That implies m equal to 1. Okay, m equal to 1 1, and this is the one. Okay, so now CF is going to be because roots are real and equal, so c1 plus c2x to the power x. Okay, okay, so now we'll find p. So because we know y equal to, the solution is going to be cf plus pi. Okay, so y is going to be, so now we'll find pi, and pi is given, right? So this is Rx is in this form. Okay, so Rx means we are solving differential equation of second order. Okay, so the linear differential equation, d2 x upon dy square plus p dy over dx plus q x qy equal to r, which is function of x. Okay, r. Okay, r and PQRR function of x. Okay, if the equation is in this form, okay, if r is in this form, a to the power ax plus phi x, any function of x, then we find particular integration in this way. Okay, so let me check. So pi is going to be here. This is 1 upon ft, that is d square minus 2d plus 1, or we can write d minus 1 whole square, right? because d square minus 2d plus 1 is d minus 1 whole square. So d minus 1 whole square is going to be that. So now we know how to solve it. This is pi, and this is going to be e to the power 3x into 1 upon, will replace d by d plus 3 minus 1 whole square, and then x square, right? In this way, f ax, so e to the power ax into 1 upon fd plus a by x. Okay, we'll solve it. So pi is going to be e to the power 3x into 1 upon d plus 2 whole square x square. Okay, so we know how to solve it, because the rx of type, if rx is equal to polynomial and polynomial of x, then we know how to solve it. I have explained in my I have explained in my previous lecture. And also, if e to the rx is only e to the power x, how to solve that also I have explained in my previous lecture. Okay, so this is going to be, the pi is going to be, e to the power 3x into 1 upon, here we can take 2 common. Okay, so we'll take 2 its whole square, right? So we'll take 4 common, so it is going to be 1 minus d by 2, 1 plus d by 2, sorry, d by 2 to the power 2 and x square. Okay, so pi is going to be e to the power 3x into or 3x by 4, you can say, or this will take this term in numerator, so 1 plus d by 2 to the b, e to the power 3x upon 4 will open its 1 plus 1 minus 2, 1 minus 2 d upon 2, then plus minus 2 minus 2 minus 1 upon 2 factorial d by 2 whole square plus so on x square, right? So we know how to open it, and plus 1 plus x to the power 1 plus x to the power n, how to open it, we know, right? 1 plus x to the power n. So this is going to be 1 plus nx plus n into n minus 1 upon 2 factorial x square plus so on. Okay, so we have used this formula to open it. Okay, so this is going to be pi is going to be, I hope guys you are able to hear me. Okay. I'm audible to you guys. Okay, okay, so pi is going to be, it is going to be e to the power 3x by 4, okay, into this one 1 minus d, 2 will get cancelled, right? And this is going to be 6 minus plus 6 by 2, so this is 3, and 3 by 4 d square, so plus 3 by 4 d square. Okay, so higher term we are just not taking, because it's a polynomial is of x square, right? So if we take higher term like d cube, then the differentiation of x square is going to be 0. So those high terms differentiation of x is going to be 0. Okay, x square is going to be 0. So pi is going to be e to the power 3x upon 4, and will differentiate it. So this is x square, will differentiate x, this is going to be minus 2x, and this is going to be plus 3 by 4 into 2x, 2x into 2x into 2, right? We differentiate, so we will differentiate x square 2 times, so this is going to be 2. So pi is going to be e to the power 3x by 4 x square minus 2x plus 3 by 2. Okay, so the solution is going to be cf plus pi. So cf is complementary function, this is sc1 plus c2 x e to the power x, right, plus e to the power 3x by 4 x square minus 2x plus 3 by 2. Okay, so this is the answer. ठीक है. Okay, next point. Next is if fourth type. Okay, if Rx is in the form of cos Ax oblique sin Ax. Okay, if Rx is in this form, then how to find particular integral? It is Pi is going to be 1 upon fd square cos Ax or sin Ax. Okay, you can write any one of them. Okay, sin Ax. So Pi is going to be so we'll replace f d square by minus a square. So f minus a square, okay, sin Ax. Okay, and then we'll solve it. Okay, right. And also if f minus a square, this value gives 0, f this value is 0. Okay, then question number 2. This is d2y over dx square minus dy over dx minus 2y equal to sin 2x. Okay, so this is the one. Okay, so for this you can see Rx is in this form, so auxiliary equation is going to be m square minus m minus 2 equal to 0. So m minus m minus 2m will factorize it. Okay, minus 2m plus m minus 2 equal to 0. So this is going to be m common, m square, right? M into m minus 2 plus 1 common, m minus 2 equal to 0. So m minus 2 into m minus 1, m plus 1 equal to 0. So value of m is going to be 2 comma minus 1. Okay, 2 comma minus 1. Okay, so CF is going to be this is C1 e to the power minus x plus C2 e to the power 2x. Okay, so this is the CF. Next, so now we'll find Pi. Okay, Pi we know that is 1 upon ft, that is d square minus d minus 2. Okay, minus 2 minus 2 minus 2 is going to be, that is sin 2x, right? Sin 2x. Okay, so we'll solve it. So we'll replace by d square minus a square, right? Minus a square. So minus a square means 2 to the 4, right? This is going to be minus 4 minus d minus 2 into sin 2x. Okay, so this is here. So what we are going to do is, we will do now minus 1 upon d plus 6 will rationalize it. Okay, so this is d minus 1. We have to remove d from the denominator. Okay, so d minus 6 and d minus 6 will multiply and divide by d minus 6 into sin 2x. Very simple. So this is going to be minus d minus 6 upon, this is going to be d square minus 36, right? D square minus 36. Okay, so Pi is going to be Pi equal to minus d minus 6 upon d square. So in place of d square we'll write minus a square, right? So minus a square means minus 4. So this is minus 4 minus 36 into sin 2x. Okay, so Pi is going to be minus minus will get cancelled, we'll take minus common, so this is going to be d minus 1 d minus 6 upon 40 sine 2x, right? Check the sine 2x, so it is going to be 2 cos common, so this is 2x upon 20. Okay, 2 we have taken common, 2 will cancel 40 by 20 times. Okay, so then y equal to CF plus PI cos 2x minus 3 sine 2x. Okay, minus 3 sine 2x. So this is the answer, right? So this is the type 4. Now we are going to solve type 5. Okay, type 5. Type 5 is for finding particular integral if Rx is in the form of x sin ax. Okay, x sin ax, then we'll find particular integral, that is 1 upon fd x sin ax. Okay, so pi is going to be 1 upon this is going to be 1 upon fd x. We can write imaginary part of e to the power iax, right? Sin ax is imaginary part of e to the power iax, or we can write pi equal to imaginary part of this 1 upon fd x e to the power iax, right? Now we'll use the same procedure which I have explained earlier. So this is going to be imaginary part of, I have written imaginary in short. Okay, imaginary part of 1 upon fd and this. Okay, so then this is going to be e to the power iax into 1 upon fd. Fd is going to be fd plus ia and x, right? By this we can solve pi. Okay, this we have already explained. I have already explained it. Particular integrator Rx is in the form of e to the power ax into phi x, right? So this is one, right? Or if same thing, sixth part, if Rx is in the form of x cos ax, then pi is going to be 1 upon fd x cos x, or pi is going to be 1 upon fd, and this is going to be x into real part of e to the power I ax. Okay, that is real part of e to the power I ax is cos ax. Okay, I ax, this is ax, right? So pi is going to be real. I will solve question, then it will clear your doubt. Okay, so this is going to be real e to the power, this is going to be iax. Okay, 1 upon f, d will be replaced by d plus ia, okay, x, and then we'll solve it. Okay, so I will solve the question, then it will clear your doubt. Okay, so let me just write down. So this is going to be now question. The question is, d square plus 2d plus 1 y equal to x cos x. Okay, x cos x. So we are going to solve it. So A auxiliary equation is going to be m square plus 2m plus 1 equal to 0. So it means m plus 1 whole square equal to 0. So value of m is going to be minus 1, right? So from here the CF is going real root, right? So CF is going to be C1 plus C2 x e to the power minus x. Okay, e to the power minus x. Okay, so now we'll find particular integration using these things, right? I have already told you. So this is going to be pi is going to be, so this is e to the power the cos x, right? So cos means real. So we'll write first we'll write like this. So 1 upon fd is d square plus 2d, d square plus 2d plus 1, d square plus 2d plus 1 x e to the power iota x, right? Because or we can write first e to the power just cos x. Okay, cos x. Okay, so then pi is going to be similar, right? So if cos x is e to the power iota x, right? So real part of real part of e to the power iota x, e to the power iota x into okay, first I'll write real part of this one. So write like this. 1 upon d square, you can write d this one, right? D plus 1 whole square, d plus 1 whole square x cos x, we can write real part of e to the power iota x, right? We can write this cos value of cos x. So now this is going to be so we can write e to the power iota x into 1 upon f. This will replace, d replaces by d plus iota a, sorry, iota, just iota plus 1 whole square, and this is x, and this is real part. Okay, so real of e to the power x ix, and this d square and this x. Now it's very simple, we'll solve it. Here is going to be real e to the power iota x, and this we can write it like, we can take iota plus 1 or 1 plus iota, common, and this is going to be 1 minus d upon 1 plus iota. Okay, this one and x we can write. Okay, so pi is going to be real part of e to the power iota x. Okay, so this is going to be into 1 upon so this is going to be 1 upon this whole square will common, or will take common, right? So this is, will open it because it is a whole in whole square, right? So 1 square plus iota square minus 1 or minus 1 will get cancelled, and this is 2i, right? 2i means 2i, right? So 2i just will be instead of this we'll write 2i, and this is going to be 1, this is plus, guys. Okay, 1 plus d upon 1 plus iota, okay, to the power 2 into x. Okay, next pi is going to be real part of e to the power ix, okay, by 2i, and this is going to be 1 plus we can write 1 plus d upon 1 plus iota into 1 minus iota, we can multiply 1 minus iota to inverse. We have taken this into numerator, right? So power minus inverse and x, we can write like this. Okay, so we'll open it, right? So this is going to be real e to the power iota x upon 2I. This is going to be 1 plus d upon this will open it. So this is going to be 1 square minus iota square, and this is going to be d into 1 minus iota. Okay, and outside x and minus 2, right? So pi is going to be real e to the power iota x upon 2I, and this is going to be 1 minus d 1 minus iota upon this is going to be plus 2. Okay, iota square 1 square 1, iota square is minus 1 equal to plus 2, right? 2, and 2 is also there, yeah, iota, right? And then to the inverse 2 into x, right? So this is going to be real e to the power iota x by 2, and we'll open it, right? 1 minus nx, this is minus 2 minus minus plus, okay, minus minus plus, so 2 d into 1 minus iota upon 2, right? So we'll take only first two terms, not other term, because higher powers there are higher powers of d, and differentiation of x is going to be 0, because okay, so this is x. Okay, so now pi is going to be real part of e to the power iota x by 2I. Okay, and this is going to be 1 minus d into 1 minus iota x, right? Because 2 will get cancelled. Okay, and there is plus 1 plus. Okay, then minus will be there because we have opened it, right? So this one, minus. Okay, so next, this is 1 minus, right? Okay, this is plus and this will be minus. So this is going to be minus. Now we'll simplify it further. So e to the power iota x upon 2I into 1 plus so we'll further simplify it further. So it is going to be 1 plus, we'll differentiate it into d, so this is x plus, okay, we'll multiply by x, so this is x minus x, differentiation is going to be 1 into 1 minus iota, right? So we'll solve, then pi is going to be real e to the power iota x upon 2I, and this is going to be x, right? So x minus 1 plus iota, okay, or we can write, and this we can write iota minus iota, right? This is right minus e to the power ix upon 2. So 2I we can write 1 upon 2I we can write minus 1 upon minus I upon 2, right? So there is I. Okay, we can write like this. And now simple thing. So this is going to be so real part of e to the power iota x, right? So which we know, right? So this is going to be real, and this is minus iota by 2, and e to the power iota x will open it. Okay, so cos x plus iota sin x, okay, and into x minus 1 plus 1, right? This one. We'll simplify it further. Okay. So this is going to be real and minus iota by 2, and this is cos x. So we'll multiply it. Okay. So this is going to be, we are multiplying it, okay, directly. So this is going to be minus iota by 2 cos x minus 1, cos x into x minus 1, cos x into x minus 1, okay, and then minus iota, this is iota, guys, okay, iota square by 2 cos x, and then minus iota square by 2 sin x minus iota cube by 2 sin x. We have multiplied this with this and this, okay. So this is going to be, pi is going to be, a real part of minus iota by 2 cos x into x minus 1, okay, minus iota square by okay, so this is going to be, minus iota is 1, right, minus 1, so this is going to be plus cos x by 2 plus sin x by 2 into x minus 1 and plus iota by 2 sin x, okay, by simplifying this, okay. So this is now the real term of this we have to take, right? So real part is this and this, okay. So here is going to be cos x by 2 plus sin x by 2 into x minus 1, this one, okay, this one, and these are imaginary, right? Iodide here, so sin into x minus 1, okay. So therefore y is going to be c1 plus c2x e to the power minus x plus cos x by 2 plus x minus 1 sin x by 2. This is the answer, guys, okay. So there is a little bit calculation in this question, okay. So those differential equations, okay, and now guys, in next lecture we are going to start with legendary polynomials, okay. So also I would request the people who haven't subscribed my channel and watch my free lectures, free live lectures, which are going to help you to